can continue now. So let me just check. So can you guys give me thumbs up real quick so I know that you guys are already in front of your computers. Okay. Okay. So did I share my screen already? Yeah. So where did we start? Right here. All right. So are we clear so far regarding with this one? So we call this one full wave rectifier with RC load. Okay. So we have here the load, the resistance, and then the capacitor. Okay, this is where we are reading the V out, wherein it will give us a ripple voltage. So are we clear? Any question regarding with this one?
Wala naman na, sir.
Those who have experience doing this one in electronics, then you guys already know how to do this one or the output, expected output of this one. Okay. Now we also have this kind of AC to DC converter, which is using a transformer. So as you guys can see right here, we have here the two inductors. So we have L1 and then L2. So in order for you to make this one as an official transformer, you have to configure this one in LTSpice. So like for example, this one. So we have the sine wave 0, forget the first one, but yeah, mostly it's 0, and then this is the voltage, and then this one is the frequency. So 5 volts, 50 hertz frequency, and then the R0 is equal to 0.1 m k L1, L2, and then 1. So this is the configuration that you need to do in order for you to have a transformer. Okay, and then the rest are pretty normal. Okay, we have 4 diodes, silicon diode, and then 1 resistor right here, or the load resistor. Okay, so in order for you to configure this one, so I'll go over with this one first. So yeah, the first one is DC offset. So since we're dealing with AC, so it should be 0, of course. So amplitude is the AC value, okay, which is 5 volts only, and the frequency is 50. Okay, and if I'm not sure if I change this one into 0.1 m. So we have a series resistance of 0.1 m. Okay, 0.1 mega ohm or milliohm. Okay, I'm not really sure with this one anymore, but yeah, just change it one into 0.1 m. I think this is milliohm, okay, not mega ohm. Anyway, so yeah, that's it for the uh, AC input. And then we have here the configuration of your transformer. Okay, so in here you have to add the schematic or the this one, the L1, L2, or the transformer itself into K, L1, L2, 1. So K is the, what is this one again? If I'm not mistaken, this is the term for transformer. So I forgot already. But here is a complete guide on how to come up with this transformer configuration right here. This one, case statement is coupling the windings. So meaning you are already combining these two inductors into two, which is having as a result of a transformer. Okay, so as I guys can see right here, we have a ratio, what which is 1:3, wherein of course from 100% it will be tripled. Okay, so it will give us an output of 3 times of your input. Okay, so yeah, that's basically it for this transformer. Or you can have, let's say, of course, uh, 3:1, or that depends on the one that you will be needing for your output. If it's a step up, then just amplify it. If it's a step down, then just uh, change the ratio into 3:1. All right, so are we clear so far regarding with this one? Well, maybe just the concept, but for this one, you guys have to experience in doing this one in real life or in LT Spice. So again, I highly recommend you guys, or I highly require you guys to visit this website right here. Okay, so this is the complete guideline on how to come up with this transformer. Okay, so just check this one out. Okay. So for now, we have here the sample voltage input and output without the capacitor. So without the capacitor or without the filter, so we still have a complete ripple. Okay, so green one is the AC, and then the blue one, is it blue? It seems like violet to me. Anyway, let's just see that this is blue or violet. So this is the DC output. Okay, so it's a pulsating DC from 0 volt to 6 volt, 6, and so on and so forth. And then if you will add 10 micro farad capacitor right here, so you'll be able to lessen the ripple. So before, from 0 to 6, it will become just 0 to 6, and then the following reading will become like 3 or 4. So 6 4 6 4 6 4 6 4. So you were able to lessen the ripple voltage as well, just by adding a capacitor. So we could say that capacitor is like a smoother, okay, to make it more smoother, or to make it more a pure DC output. Okay, and then if we change the value of the capacitor into 100 microfarad, then we can have an output of, let's say, 6 to 5.5, 6 to 5.5, 6 to 5.5. So it's now almost a straight line. Okay, so this one is already considered as a pure DC output. But if you're a perfectionist, then you can change this one into a higher value of capacitor. Okay. Well, I just have some theory right here. So why happy rectifiers are generally not in use in DC power supply? That's because with the happy rectifier, the output voltage is 0 for half the time. Okay, the type of supply available from happy rectifier is not satisfactory for general power supply. Okay, that is why it is generally not used in DC power supply. If possible, we want to attain something like this. So if not, almost a perfect DC output, a pure DC output, which is purely, let's say, 6 volts only. Okay, so here are my references for this PowerPoint presentation, and yeah, that's it for the ACDC. So are you guys able to understand everything so far? Hello, are you guys still around? So any question or clarification regarding the AC to DC module?
Wala naman sir, gets naman ata. Kasi sir, since di ba parang na-brief na natin yan nung sa electronics natin.
Yeah, that's right. Okay, so there's really no question. So again, if ever you have a question in the future, so just message me on my Canvas or on my Facebook account. All right, so the last module will be EC to EC2. So this is just a 11 slide. Well, in fact, this is maybe 9 slide, because the last is the reference and then the end of PowerPoint presentation slide. Anyway, so again, what is a DC to AC converter? So it is an inverter wherein it's converting our DC into an AC supply. Okay, so let's see what is the thing that we need to discuss right here. So yeah, this is one thing that you guys need to remember when it comes to DC to AC. So we call that one inverter technology. Okay, and generally they operate with 12 volts and commonly used in applications like automotive, lead acid technology, or photovoltaic cells, or etc. But mostly we have inverters in, I think, if I'm not mistaken, in washing machine. Okay, to save more energy, or it's recycling the electricity that's receiving, let's say from the rest are converted, the extra are converted from DC, and then it has the ability to convert that one into AC, for it to use the AC power. Or we always, or we, yeah, I think in all of the cars, this is what we have, from a battery into a AC, okay, power. So yeah, we charge our phone, right? Okay, of course, it need an AC output. Okay, so of course from AC it will be converted to DC again, since it has a converter inside of that battery brick. Okay, so yeah, mostly that is where we use that DC to AC. So it's coming from our battery, okay, battery of our car, and then it will be converted into an AC. Let's see, 120 volts AC, or 200 volts, depending on how much energy you need. Okay, so a transformer, coil system, and a switch is the simple circuit used for an inverter. So we have a transformer, and then we have a switch for that one. So in AC to DC, we only have transformer. But for the DC to AC, we have two. So we have transformer, coil system, and then a switch, okay, for the inverter. So a typical transformer can be connected toward the DC signal input through a switch to oscillate back quickly. So due to the current flow in bidirectional in the primary coil of the transformer, an alternating current signal is an output throughout the secondary coil. Okay. Well, I guess this one is quite ambiguous for now, but let's move on for you to be able to understand what's really happening on how to convert DC to AC. So DC to AC converter circuit using transistors is shown on the right. So this one is now using, this is another type of circuit, which is using a transistor to convert DC to AC. So yeah, this one is quite complicated to understand, but yeah, here is the battery, which is the original source of your energy. And then we have here the step-up transformer, and then the switch. Okay, so yeah, I know that it's quite complicated. We have resistors right here. We have capacitors right here. Okay, we even have like the NPN or the PNP transistors right here, the 2M222. We even have IRF630, which is another kinds of transistors. Another IRF630 right here. But yeah, here are the things that you will need if you're going to use a transistor as a converter. Okay, of course, it still needs a step-up transformer, not just a resistor, capacitor, and then the transistor. Okay. Anyway, so yeah, this one is your way in order for you to convert your 12-volt DC into a 220-volt AC converter. Okay, with using simple transistors. It's actually simple, but for me, it doesn't look simple in this kind of circuit. Okay, so the inverter executed in the circuit can be a square wave, and it works with devices like which do not need pure AC sine wave. So if you have pure DC, just take note, we also have pure AC sine wave. So what are those not pure AC? If it's not the sine wave, then like for example, square wave, what else? Different kinds of wave. Forgot the other term, but yeah, we only have one pure AC, which is the sine wave, and then the square wave, and then the others are not a pure AC. Yeah, AC wave, rather. Okay, so I was about to say sine wave. So just remember that if it's pure AC, then it's sine wave, and then the rest are not pure AC anymore. Like for example, square wave. So here are the required components. So we have here MOSFET, transistor, capacitor, resistors of 12K, two resistor of 680 and so on and so forth. Okay, for those components that you'll be need if ever that you want to do this one in LD Spice. Okay, so here is a working circuit. From DC to AC circuit can be separated into three portions, namely the amplifier, transistor, and then an oscillator. So as the AC quality frequency is 50 Hertz, then a 50 Hertz oscillator is used. So of course, you can change this one into 60 hertz since here in the Philippines we're using 60 hertz. So if you need 60 hertz, then you have to use an oscillator which is also 60 hertz. So this can be attained by designing unstable multi-vibrator. Okay, so search this one on the internet on how to design a stable multi-vibrator. So this one I will generate a 50 hertz square wave signal, and then the oscillator can be formed using the resistors like R1, R2, R3, R4, and then capacitors like C1 and C2, and resistors like T2 and T3. Okay, or you can sometimes you call that one L1 and then L2. It's like what we have. My apologies. This one is transistor, not inductor. So yeah, this one is correct. My apologies on that one. So it's T2 and T3. So every transistor generates square waves, inverting, and the frequency will be decided by the resistor and the capacitor values. So the frequency formula for the generated square wave with the stable multivibrator is F is equal to 1 divided by 1.38 times R2 times C1. Okay, so it's just the formula for the frequency. Okay, so what will you come up with 40 hertz? Do you need 60 hertz? Do you need 30 hertz? So yeah, just come up with the correct values of your R2 and then C1 in order for you to get the correct frequency that you'll be needing on your system. And then the oscillator inverting signals are improved with the two power MOSFETs such as T1 and T4. And these signals will give to the step-up transformed by its center tap associated with 12 volts DC. So in other words, this one is the explanation and how to set up the values for your converter, or this one with the use of MOSFET, transistor, and then resistor. Okay, so here are some limitations of DC to AC. Of course, if you're going to convert DC to AC, it has a disadvantages or cons. So the transistors usage can reduce the circuit efficiency. Okay, so that is one thing that you guys need to uh, uh, take note. Okay, or say be familiarized with if you're going to convert a DC to AC. So the usage of switching transistor can cause a crossover distortion. So within the output signal, so we have this distortion. However, of course, we have solutions with this distortion here, but this limit can be reduced to some level by using bias inductance. Okay, so yeah, it already has a solution on how to solve this distortion if you're going to uh, come up with DC to AC converter. Anyway, see, here are some applications of DC to AC. So we have here, of course, the number one is this one is used in vehicle to charge their batteries, DC to AC, and then mainly used for driving low power AC motors and used in a solar power system. Okay. Thus, this is all about DC to AC converter. This can be used in DC transmission lines for transmitting power to loads in uninterruptible power supplies. So this can be used to convert direct current to alternating current, and converters can be used in industries where consistency is the problem. So if you need maybe the other way around, wherein it says here converters, uh, where is that one? Yeah, converters can be used in industries where consistency is a problem. If in your area, the consistency of AC is a problem, like if you really need a consistent value of, let's say, negative 220 to 220, so you can come up with your own machine or with your own converter. Okay, like you need to convert everything in DC first, and then from DC you can have a AC supply. Okay, so of course with the use of UPS. Okay, this uninterruptible power supply. Though this one is quite expensive, like maybe three for let's say PC, which can store I'm not really sure with the kilowatts, but yeah, let's say it can run your laptop for 30 more minutes, 30 to 1 hour. So that's already maybe 3,000 peso to 5,000 peso. So yeah, just in case that you need that kind of supply, let's say to a certain situation, but I cannot until now I cannot think of a situation wherein you'll be needing to convert the AC to DC first and then use that one from DC to AC. Okay, but that is one example. Let's say you need to use that one on your laptop. Okay, so of course you're going to buy UPS in order for you to store that one into AC. Okay, from DC to AC and then use that AC into something else. Okay, so yeah, those are some applications on why we convert DC to AC. Okay. But of course, there's a lot more examples out there why you need to convert DC to AC. But of course, mostly we don't convert DC to AC because we can already have the AC power in our outlet. Okay, so that is why DC to AC is very uncommon. Okay, since originally we already have the AC, unless you want to have a double conversion. So AC to DC and then DC to AC, which is very impractical. Anyway, so why do we require changing from DC to AC? Again, most of the vehicle, again, this one is mainly used for in our cars. Okay, so of course we don't have that outlet. Okay, we don't have that connection to the electrical pole. Okay, wherein our car has an outlet of 220 volts. So we use our DC voltage and then convert that one into AC voltage. This to come up with a 12 volt my bad, my apologies. Just come up, let's say, with 120 volt AC voltage. So going back here, most of the vehicles use their powers from a battery of 12 volts, but in some cases, a 24 volt battery can be used also. So it is very significant to know the vehicle voltage due to the voltage rating of the inverter we choose must be equal the battery's voltage. So in any case, the battery gives DC, which means the flow of current will be continuous from the battery's negative terminal to the positive terminal. So in DC, the flow current will be only in one direction. Thus, DC is extremely helpful. However, batteries can be normally provide somewhat DC power with low voltage. So several devices require extra power to work correctly than DC can offer. So thus, this is all about DC to AC converter, how to convert DC to AC. Converter enhances the DC voltage to alter it into AC before transmitting it out to give current to a device. So primarily, these were intended to perform the reverse for converting AC to DC. Because basically, these converters could be worked in opposite chips to reverse effect. So this is called as inverter. Okay, so like more concept or why we need this DC to AC conversion. And yeah, we have two types of converter. We have the voltage source converter and then we have the current source converter. So from DC to AC, from DC to AC. If you need to convert the voltage from DC to AC, so you'll be needing a capacitor for this one. Okay, and it's parallel with our voltage input. And then if we need a DC current, let's say DC power current into a AC current, then you have to use an inductor, which is now in series with our voltage input. Okay, and yeah, here's another sample circuit of a DC to AC inverter. So we have here four diodes. We have four silicon diode. We have the resistance or the RL couple. Okay, and yeah, we have here the inputs, and then we have here the well, there's one capacitor. If I'm not mistaken, VDC divided by 2. But there is no label that this one is capacitor. But this one is a symbol of a capacitor, and then it's the same here that the voltage output will be divided into 2, and then once they are combined, then we have here now AC output, if I'm not mistaken. Oops, my apologies. This one, why we have DC to AC right here, but in here we have AC to DC. Let me just check real quick. I don't know if this is a typo, Supposedly this one is DC to AC since we are in DC AC.
DC to AC converter. Rechargeable batteries are the best option to store electrical
Wait a second.
energy as
So
we
my
to backup
laptop
power
just hung.
warehouses.
But yeah, this one is
We know
DC
that
to
the
AC.
electrical output
So
of
this
batteries
one right here is a typo. Okay, my apologies with this one. This one is DC to AC. Okay, so this one is the sample circuit of a DC to AC, not AC to DC. Okay, so you will see here that this one is also DC to AC. Okay, so yeah, one more thing, another term for inverter is called converter, right? Anyway, just check this video later on, which is explaining this sample circuit like this. And yeah, that's it for this video. I mean, for this presentation. Got it. So here are my references, and then yeah. So that's all for the AC/DC and then DC to AC. So any question or clarification so far? So while I'm waiting, let me just edit this one so that I won't forget anymore that this one is DC to AC. Question, guys, or clarification? DC to AC. So were you guys able to, it's having an error since we are using the file. So were you guys able to follow everything?
Yes, sir. Understood now.
Okay. So
Yes,
again,
sir.
just a reminder. Let's go back right here again. Number 8 is DC to AC. So this is your main goal actually, and how to come up with that circuit. So this is the main challenge of this laboratory because AC to DC, yeah, AC to DC is like a bonus already. You already have a lot of examples on how to convert AC to DC. Okay, but still, you guys need to do this one for your ninth laboratory. So the only challenge is the DC to AC. So make a working circuit on the these files and how to convert DC to AC. Yes, you can search on the internet for more information or for more tips on how to do that one on LP files. Okay, so yeah, that's it for now. And the due date of your 8th and 9th lab will be on, so I haven't edited this one yet, but yeah, it will be due on February 4th. So you guys have exactly 2 weeks from now. So the same with your case study. So if you guys don't have a question anymore or clarification, then I guess it's already. As usual, thank you guys for coming. I really, really appreciate it. And then again, my apologies with my voice since I don't know, maybe this is the after effect of my cough. I don't have a cough right now since I'm already good, I guess. Hindi naman ako inuubo. Pero yeah, I don't know. But my voice stays as it is. As, you know, in last few days, 3 days ago, ganito yung boses ko, parang ang lalim. Anyway, so goodbye. And yeah, let's just meet again next meeting. So goodbye and thank you guys for coming. And keep safe.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you.
Thank you, sir.
Sir, question, sir.
Yes.
Sir, about dun sa soft design. Sir, yung sa lecture subject ba tsaka dun sa ano sa lab subject? Sir, pareho ba yung dapat na plan or magkaiba sila? Yung para dun sa title proposal, sir.
Title proposal. Sino ba yung lecture mo? Ako?
Sir, kayo rin, sir.
Lab, tapos lab ako din.
Yes, sir.
Because my plan, And here is in lecture, it's this pure lecture. Meron bang title proposal sa lecture?
Hindi sir, yung sa SLDC model sir, yung by group.
Hindi. Kahit iba yun. Kasi that's just for the sake of activity. You can just have one e-commerce, right? And then you're going to choose two best SDLC method that you think is best fit on that e-commerce. So any will do as long as you were able to, explain why that is the best methodology for that e-commerce. And then for the laboratory, you have to very careful on that one since that is the kung ano man yung pinopose nyo, yun na yung magiging final project nyo.
So for example sir, like we want to create an app, ganun ba sir? Parang yun yung sa lab, pero yung sa
Lecture
sa
is
lecture is iba na, parang e-commerce na.
mga activities lang yun and then just the concepts. And then yun talaga yung final project nyo will be on laboratory. Okay.
Okay. Thank you sir, thank you for clarifying that sir. Share ko na sa team ko. Thank you sir.
And
Bye sir.